And welcome to 7.1 for Algebra 2. It's all about inverse variation. So inverse variation is usually discussed with direct variation. Direct variation follows y equals a times x, where a is just some constant. For example, like y equals 2x. If I were to graph that, I would get something like this. And as we see, as x's continue to go up, the y continues to go up. So direct variation works like that. As x goes up, y goes up. We even see the inverse is true. As x is going down to the left, my whole graph is going down. So my y value is also decreasing. Inverse variation is a little bit different, where if I were to graph it, let's say something like y equals 2 over x, it would look something like this. Where, as we see, as x gets bigger to positive infinity, the graph is going down. So inverse variation just means as x goes up, y goes down. Basically, the difference, and again, a is just some number, is that I'm isolating for y, like we usually do, and if I'm multiplying between the a and the x, it's direct variation. If I'm dividing between the a and the x, it's inverse variation. So let's take a look at a couple. Here we have xy equals 5. So I want to get y by itself, so I'm going to divide both sides by x. So now we have y equals 5 over x. Y is by itself. I'm dividing. That looks like an inverse variation pattern. Letter B, I have y by itself, but I have x minus 4. The x and the 4 are being subtracted. They're not being multiplied or divided. So this would actually be neither. Here, we have to get y by itself, so you multiply both sides by 2. So we get y equals 2x. That's multiplying, so that would be direct variation. Here, y is by itself. We have 6 times x. That would be direct variation. I want to get y by itself, so we're going to divide by x. So we get y equals negative 0.25 over x. That's being divided with the x on the bottom, so that would be inverse variation. Here, subtract the x, get the y by itself. We get y equals negative x plus 10. That would be neither. Okay. Now, let's say I'm given a table of values. So here, I have all my x values, and I have all my y values, but I don't have any a values. So I need to solve for a. So theoretically, if I'm looking at this direct variation, we have y equals ax. To get a by itself, we would divide both sides by x. So in a direct variation, if I'm isolating a, I'm technically dividing. Same thing over here. I can multiply both sides by x to get a by itself. So in an inverse, to get a by itself, I am multiplying. So what I need to do is I need to show that one of these relationships is consistent, aka I get the same values. So for each thing, I test it. So for example, y divided by x. I'm going to do negative 12 divided by 2. That gives me negative 6. And move on to the next one. Negative 6 divided by 4. If I type that in my calculator, I get negative 1.5. I'm already going to see that I'm not going to get the same values by dividing. So I can skip the rest of it. My result or my answer has to be the same in every single situation. So let's try multiplying. 2 times negative 12 is negative 24. 4 times negative 6 is negative 24. 6 times negative 4 is negative 24. And 8 times negative 3 is negative 24. Now, because I got the same answer every single time, I know that x times y equals negative 24, or more specifically, that a equals negative 24 in this relationship, which means this has to be inverse variation, because when a equals x times y, then I know I'm inverse. Letter B, I would try the exact same process. So let's start with 2 divided by 1, that's 2. 4 divided by 2, that's 2. 8 divided by 3 in my calculator, that's 2.67. So I know that that's not going to be consistent. X times y, 1 times 2 is 2. 2 times 4 is 8. So that's not going to be consistent either. So neither of them work. So I would say this is a neither. Over here, y divided by x. So I'm going to get 60 divided by 1, which is 60. 30 divided by 2, which is 15. So not the same thing, so not going to work out. X times y, 1 times 60 is 60. 2 times 30 is 60. 3 times 20 is 60. 4 times 15 is 60. So again, I know that x times y equals 60, and that therefore a is 60, and this is an inverse relationship because it's the xy one. Okay. Right, an inverse variation. So the variables x and y vary inversely. So I know they have to have the pattern y equals a over x. And I'm even given the x value and the y value, so I'm going to need to solve for the a. So let's just plug those in. So I get 5 equals a over 4, and I can multiply both sides by 4. So a equals 20. Therefore, my equation is going to be y equals 20 divided by x. It says, then find y when x is 2. So I'm just going to plug in 2 for x here. So y equals 20 divided by 2, or y equals 10. So a little two-part question there. Okay. Here, same idea. Let's plug in -1 and 6. So I'm going to get -1 equals a over 6. Multiply both sides by 6. We get a is -6. Therefore, y equals -6 over x. We can then plug in 2 for x. So y equals -6 divided by 2. Y equals -3. Same thing over here. So we're going to get 16 equals a over 1/2. Multiply both sides by a half. What's half of 16? That'd be 8. So a equals 8. So y equals 8 over x. And then, of course, we can plug in 2. So y equals 8 divided by 2, or y equals 4. Next, we have a story problem here. It says in time t hours, it takes a group of volunteers to build a playground varies inversely with the number of n of volunteers. So varies inversely. I know it's going to have the pattern y equals a over x. But I'm going to use t and n. So I'm going to get t equals a over n. Interestingly enough, it doesn't actually matter which letter goes where. For example, if I did n equals a over t, and I wanted to multiply both sides by t, so I have tn equals a, and I wanted to divide both sides by n, I end up with the exact same impression. T equals a over n. They are equivalent. It doesn't matter which one you do. The reason I chose T by itself is I saw down here volunteers. I'm going to start plugging in. And if we remember from the prompt earlier, volunteers was our N. So I want T to be by itself. Now I was thinking about this. If it says it varies inversely, so as one goes up, the other goes down. Well, if I have more people helping, should it take less time for them to accomplish this task? Yeah, that's absolutely true. Now, it also says it takes 10 volunteers 8 hours. Well, volunteers was N and hours was T, so I can plug that in. So I'm going to get 10 equals A over 8. Multiply both spots by 8, we get A equals 80. So we get T equals 80 over N. Lastly, I have 5 volunteers and 25 volunteers. It's asking how long. So I'm just going to plug those in. So I'm going to get T equals 80 divided by 5, and T equals 80 divided by 25. So that would be 16 hours and 3.2 hours. As always, thank you for listening, and I hope you have a great day.